I mean, I think if you asked me on my first day when I started at Trimble years ago, I loved LiDAR. I thought it was the coolest thing.
Okay.
I loved point clouds. And then I honestly don't know when, but somewhere along my time here, I realized that to me, I feel like my philosophy is now, how do we make hardware that most enables the software to help you get to that answer faster, whatever the answer may be in the context of the problem. To me, optimizing the hardware, I mean, we specs at the end of the day on hardware are all great and fun, but at the end of the day, our customers want answers. They don't want a faster hardware or anything. They want a faster answer. And how you use the software and the hardware in tandem to get to that answer faster is what's important.
On this episode, we have Alex Okscin. He's a product manager on Trimble's reality capture team based in Westminster, Colorado. Alex shares his perspective on what is reality capture. He does a bit of a deep dive into some of the technology. So if you're interested in that, there's some good elements of that. And even though Alex is a big fan of the technology, he's really most interested in what he calls solving the customer's problem. So at the end of the day, what are you really trying to do with reality capture? And then designing tools to address that need. And finally, he covers a few scanning workflows. So if you're just getting into scanning or if you already use it, he shares some of his tips and tricks on that. Thank you for tuning in to the Point Taken podcast by Trimble.
Just to start off, could you break down what does reality capture mean to you as a technology?
Yeah, so I guess kind of starting off, so reality capture was a term that kind of got really popular a few years ago. Maybe it was around 2022. And to me, it at first encapsulated 3D scanning and kind of grew to anything that really relates the physical world to the digital world and how you can reference back to the physical world, whether it be in a cloud or desktop environment off-site where you're able to, whether it be a point cloud or imagery, but being able to really reference data captured on that site and doing it remotely.
I think, do you find that that's maybe similar to what even the surveying industry went through when they were surveying, and now a lot of people like to refer to it as like the geospatial industry, because there's still core surveying and core surveying instruments, but I think even a lot of surveyors were like, well, we do so much. A lot of surveyors even expanded their focus into what they were doing more with drones and more with scanning even. And so I think they almost needed to grow. Is that where you feel like laser scanning, 3D scanning needed to kind of mature a bit into a new name? Or?
Yeah, no, I think totally. I think that's almost exactly it, where, 3D scanning was kind of like this niche that existed and people knew it was there, but it was often seen as something that was very complex or only a few people knew how to do. And I think reality capture now encompasses it more to something that's acceptable and accessible for more people in the industries to kind of grab onto. And I like that example of where surveying kind of grew with like the advent of drones and things like that, where it's not just a total station and a GPS receiver anymore. There's a lot more things that are kind of encompass it now. And as the industry grew, the terminology changed.
I have this question that basically says, why are people doing this? What is the goal with reality capture? Is that possible to answer that question, or is that too broad of a question? What are people doing with reality capture?
So I think at the end of the day, one of like the beauties of reality capture is it's kind of like the kids game telephone, where you can have somebody describe something on the site and they describe it to somebody else, and that other person has to go action it. But this kind of, I'd say reality capture brings that context of reducing any communication errors across parties to make sure that whatever does need to get done on site, you're not just talking about it. And if we described something and had somebody draw it, we'd probably have two things that look very different. But having that real context of what this is and what the problem is or what needs to be actioned in that physical site, in a digital world, it enables them to have better communication across stakeholders.
It's kind of an interesting answer. So you're saying it's not as much about what people are doing with it, but what they're kind of solving is better communication. It's a better snapshot of what's out there.
I mean, it's almost similar to I mean, 2D plans used to be kind of the golden standard, and in some areas, obviously, they may still be, but when you have that 3D model and kind of how that grew, it's just like that in terms of the context of seeing things in 3D versus seeing them in the real world, in the digital world.
Yeah, yeah. So, and kind of for today's conversation, I would say let's keep it to terrestrial systems because reality capture can really be from satellites to space, all sorts of things. What would you say is in the range of terrestrial scanning systems? What types of systems are out there?
Laser scanners kind of range from, those handheld lower fidelity data to the high fidelity tripod-based scanners that are going to give you very accurate measurements, all the way to integrating them onto mobile mapping systems, whether it be on a car, on a backpack, or even on a drone.
Okay, so you've got handheld, tripod, backpack, and mobile. Would you put the handheld and backpack in the same class?
Yeah, I'd say they're kind of, it's just a different form factor of actually using it, but in reality, if it's in your hand or on a backpack, it's one and the same.
Yeah, okay. And do you kind of differentiate types of reality capture systems in terms of the precision they can get? Like, is there a order of magnitude cutoff where you're like, this is a consumer system, this is a commercial survey grade system? Is there a cutoff at different points that you say that?
So, I mean, it really comes down to what type of application people are looking at. So, like, if you're going to go do some pipe modeling, for instance, you probably don't want to use an iPhone to try to get those answers from that LiDAR.
Yeah.
Whereas historically, a terrestrial system on a tripod has been tried and true to be able to get enough rich data and accurate enough data that you'll be able to model those pipes back in the software. So I wouldn't say that I have like any criteria of only use this instrument for this type of work, but I think I think a lot of the industry probably could do a little bit more homework on what the accuracies actually mean in interpreting these data sheets, and that's something I'm pretty passionate about, of what those specs actually mean in the real world versus in a lab where a lot of these spec sheets are created.
Oh, right. So even though the system says you get X amount of millimeter precision, how does that translate when you've combined a bunch of point clouds in a system? Like,
if you look on the data sheet of and basically any terrestrial scanner out there, you'll see that they are specifying at specific albedos, which is essentially, it could be the color and the texture of the wall that they're actually scanning to. And in the real world, everything's not like it is in a lab. So you have to do your homework to understand what type of accuracy you're actually really getting in the field.
yeah, so that's fair. I guess I still wanted to pull out of you this, like, give me a, like, 2 millimeter, 5 millimeter. I think I wanted a cutoff of, like, where does an iPhone different than there's got to be a difference, right?
Well, yeah. I mean, fundamentally, there's a difference between an iPhone and like a terrestrial laser scanner. But at the end of the day, if you operate a terrestrial laser scanner really poorly, you might only get as good of the data as an iPhone if you really do it wrong. So it's more about the best practices of how you're actually using that instrument and understanding what its limitations are. Because in some contexts, scanning with an iPhone can be all you need. And yes, you might not get those millimeters, but you might not be chasing millimeters. Whereas with a terrestrial scanner, they're going to have, like, for instance, some of them have a minimum range of, say, 30 centimeters to 50 centimeters. And if you know you need to get into a tight, confined space, that might not be the right tool. And for what's available, it might be some sort of hand scanner, or maybe the iPhone's good enough depending on what answer you're trying to extract out. But yeah, in terms of what tool is built for these, I mean, people have gotten creative, and it's not as easy as you can stick one instrument to one specific application.
Interesting. You won't get into a spec war with me. So I didn't know you were going to say that, but I think that is probably refreshing for a lot of like Trimble customers, but people that are surveyors and engineers to know that it kind of comes down to how well that they can use technology, not how well technology can get. It's not like you're putting this X9 scanner, that's what makes it work. It's you operating the X9 scanner as the right tool for the job that really makes that work. And so it's refreshing because it comes back to like the empower of keeping yourself educated, best practices. You still can't forget about that stuff.
Yeah, and like, I mean, I'll give you an anecdote. When I started using terrestrial scanners about 8 years ago now, I did not fully understand how they worked, and I thought I could do creative things like, oh, I don't need to scan inside the doorway. I can just have the door shut on both sides, and I can probably just glue them together. Totally did not work. But like, I'd say a lot of understanding where a scanner can be used really just comes with experience of, in some cases, just trying it out and even comparing it to how you do it a different way and seeing what it's like. Because I think there's a comfortability factor too with if you're new to terrestrial scanning and you know how to do that job with, like you've been doing the whole entire time with like a tape measure or whatever tool it may have been in the past, having a point of reference of where the limitations are of, I know what this is the answer I need to get, how do I get it with this old method versus using a terrestrial scanner or something new.
Yeah. What would you say would be like 2 or 3 really interesting challenges for someone, even that has scanned a lot, just to like get better and kind of learn about scanning? What would those be?
So, I mean, one of probably the easiest ones is right away you'll learn pretty quickly that reflective surfaces are going to give any scanner a lot of grief. You're not going to be able to easily just magically get rid of all of the issues that reflective surfaces cause. But go scan something that has, the worst conditions, as many mirrors and glass surfaces as you can, and make that look good. And if you can do that, that's a really great starting point. I mean, one of the other things that I would say is if you have access to a scanner or you want to try one out, one of the easiest things you could do is just go scan your house. And I mean, you know what your house looks like, and try to see if you can make it look as good as possible, just to understand, I'd say probably putting the scanner where it needs to be is one of the biggest challenges. And that has been solved a lot by the field softwares. But when I started, it was you go back to the office, you load in all your point cloud data, and I didn't take enough scans here, and I can't get these to come together. And I mean, by doing that and having that painful experience by going back and forth, you learn, do I need to put another scan in? I'm going to put one in just in case. And eventually you get to the point where you're like, I actually don't need that scan. I know I have enough overlap and these 2 scans were close enough. So yeah, I'd say go scan your house. I mean, it could even help you if you need to remodel your kitchen or anything like that. You can learn a lot just from a personal experience of how these instruments work and operate and where they're successful.
Are there like 4 steps or 10 steps to a scanning workflow of scan, edit the data, publish it out? Is that too simple? Like, how would you describe the steps it takes to do a scanning workflow?
Okay, so I'll leave it at just getting to a quote-unquote perfect point cloud where the data is ready to be used to go into whatever system. So really, I'd say the first thing that you should always do is assess the site and the environment that you're going to be scanning in. You can, once you kind of gain experience, you'll be able to kind of understand how many scans it's actually going to take just by looking at the site most of the time. And then really, I'd say scanning is your natural next step. And this nowadays is all about, you have registration essentially in the field with you. So you kind of get, it's kind of like training wheels of like, if you don't get a good registration in the field, then it's likely not going to work in the office either. So it kind of helps build up your confidence in where you scan. But really the scanning process itself is pretty streamlined now. You could probably go out and scan this whole building pretty easily within a day. But after scanning, of course, you do want to, a few things to consider there too is what type of density you're looking for, what range your scanner is so that you know that you're getting far enough out of if there's certain things that you care about, whether if the building's really tall or kind of what creative tricks you can do to get some areas that might be challenging for some scanners. But once you're kind of done with that scanning, the next is really the processing. So in some cases, that will take place in the field with you, and I think that's something I really like about the way our systems are working with kind of that core competency of being able to leave the field with confidence, which I think is a huge thing in 3D scanning of you might only have that one chance to go to that site and capture all of the data.
So the confidence is that you got it, or is the confidence that you got it and the data is good?
Yeah, I'd say that you got it and that the data is good to be able to register those scans properly in the Office software. And then, processing, that's probably, I'd say, kind of one of the trickier things when you're first starting out is really being able to understand what scans go together. What I always try to do is take some field notes. If I go down, let's say there was a long corridor and you end up going into all those rooms, but then the corridor ends and you have to go back to like the center of the building, you want to make sure that you understand kind of where those scans are. So you can use like things like labels or just field notes to be able to say, okay, that section over there is good. So then if scan 31 is at the end of that hallway and then you go do scan 32 here, you know that you need to tie scan 32 back into 16 or whichever one is closest to make sure that you're creating a cohesive model.
Okay.
And then after you process it, then you're going to want to probably segment out some of the point clouds. So it's always common. Obviously, you can have people walking through your scans. You'll learn quickly when you start scanning that you want to avoid being in the plane that's actually scanning with a scanner like this. But those people don't know that, and they're going to walk through your data. And there's one clicks now to be able to get people out of your data, but really being able to clean that point cloud to make it ready would kind of be the final step.
So if you had to list them, how would you say it, like in one sentence? What are the...
Yep, so you start out with a kind of a pre-site walk to just kind of understand what you're getting into, doing the actual scanning job, then of course leaving the field with semi-registered data, so call it pre-registration, and then going back to the office and really tightening your registration to make it into something cohesive to send to a software to get your answer or your deliverable depending on what you're doing.
Cool. Okay, well that sounds super simple. Do we still need targets? Have we solved the need for targets today, or what? What's the answer on that?
So it depends, of course, but I'd say in general, you don't need targets depending on what type of accuracy you're trying to get out of the instrument. If you're doing kind of lower fidelity things where, I don't need this to be within millimeters, but a half a foot's good, you can just use cloud-to-cloud registration, which is essentially an algorithm that's just going to put 2 point clouds from stationary scans together and marry them up. Of course, there is a pairwise registration too, where you can pick common points between those two stations if cloud-to-cloud fails. But really, that depends on what the environment is. But targets are still necessary for some applications where you really want to nail down that point cloud and get things as tight as possible. So any environments where you're really chasing millimeters, you still want to use targets as a best practice.
Okay, good. Is that also the best practice if you have to tie it into some known coordinate system? Do you set up targets over control points? Is that a thing, or?
There's a few different ways to do it, because you could lay those targets out before you scan, and then you can shoot them in with a total station or a GNSS if you're outside to get it onto control. But some people, they don't put up targets and they're still getting it onto control, and you can essentially just use natural objects of tying control points to benchmarks that aren't going to move. So like you could easily put a control point on a curb or something like that. And you can kind of get away without using targets to put it on control.
Do you want to get into like some of the technologies that are used in scanning and describing how a scanner works? Do you want to tackle those, or it's up to you?
Why not?
Okay. Well, I think we hear LiDAR a lot, but tell me within laser scanning, what are the core technologies that are involved, and just at a high level?
Yeah, so I mean, some of the sensors we're considering are obviously LiDAR, so using an invisible laser. Then we have cameras and photography, which are really good for contextualizing a job site. And then I'd say kind of somewhat more niche things. So obviously a lot of these instruments will have an IMU to calculate some sort of trajectory or positioning. But then I'd say getting into more niche things like how you integrate GPS and things like that. But kind of the other side of that is like a lot of these sensors and the hardware is, again, it's limited by the software and what that workflow is and what you're trying to achieve, because LiDAR isn't the end-all be-all of anything, but it helps provide that workflow to get to an answer, and that's what people want. They don't. Nobody's asking for, oh, we need a LiDAR, we need a camera. We need this answer, and we need it contextualized, whether it be spatially or whatever the constraints are. But it's how that hardware can enable the workflow to get that user to that answer.
I think I initially thought laser scanning, LiDAR, you almost only used to see the points, and they were colored with like distance or intensity or something. Are you kind of saying now that where we're currently at, the photography is actually the most important, or?
So the LiDAR is still really important.
Okay.
I guess kind of where the industry is heading is, I'd say we're kind of at diminishing returns for, I mean, you can keep making these scanners faster and collect more data, but that's all good and fun. But what we need to do is make the workflow of getting from point cloud and LiDAR to an answer faster. That's really kind of the key. Is yes, we could probably make a laser scanner that shoots, I don't know, 10 million points a second, but what good is that if the back end is still, oh, you still have to do this same exact workflow, right, and it takes the same amount of time, but you're using 4 times as much storage. So it's more about how cameras today, people are working remotely. The person who was laser scanning on site may not be the person that's in the office, and how you give the power of giving the people in the office that context of as if they were on site using actual images and video or whatever it may be that's in RGB and things that our brains and our eyes are used to, is to me helping bridge the kind of foreign concept of a point cloud and making it so that the person in the office can understand that job site better to be able to give maybe even a better answer or get to that answer faster.
It sounds like you and maybe the team you work in is just very optimized around what are people trying to do with it. We have to always address that, and then you back in the technology of like, okay, do we need a better camera? Do we need more LiDAR points or less? But really starting with the problem you're trying to solve. I probably should have expected that, but it's interesting to hear you say that instead of just hear you be like, yes, you need precision and this has the most accurate arc angle or something like that. You really get after the customer problem. It's interesting to hear.
So I mean, I think if you asked me on my first day when I started at Trimble years ago, I loved LiDAR. I thought it was the coolest thing. Okay. I loved point clouds. And then I honestly don't know when, but somewhere along my time here, I realized that to me, I feel like my philosophy is now, how do we make hardware that most enables the software to help you get to that answer faster, whatever the answer may be in the context of the problem. But to me, optimizing the hardware, I mean, we specs at the end of the day on hardware are all great and fun, but at the end of the day, our customers want answers. They don't want a faster hardware or anything. They want a faster answer. And how you use the software and the hardware in tandem to get to that answer faster is what's important.
Yeah, and I hear that from like Trimble customers, people that surveyors, engineers, contractors. They a lot of them seem to like that challenge of almost like, how do I solve this problem? And maybe it's this scanner, maybe it's a mobile system, maybe it's a GPS topo. Like they like trying to figure out how to tackle the problem, and that's what's fun for them or enjoyable. But also what makes them probably good at what they do is they're not just like, oh yeah, like this is the thing we have to use. It's like, let's take a look and find out how do we put together the best solution for it. So
yeah, and I think like part of it is like the hardware is very easy, it's tangible, like it's exciting, like it's awesome. Like I do love this stuff, but yeah, I think contextualizing of like how you actually make that hardware be more efficient for what the workflow is at the back end is what we really need to focus on.
Yeah, maybe from a branding standpoint, but from your perspective, how would you like Trimble Reality Capture, the team or the products, how would you like to be known? What would you want to be known for?
Yeah, so I think for me, and honestly, this is probably the reason I joined Trimble in the first place, is the thing, like first, I like the culture is great, but the thing that really attracted me is that confidence. And I had felt that like not just on the scanning side, but if you look on kind of anything in at least field systems where it is kind of a mix of hardware and software, is kind of the confidence and like the excellence of like, we want to make sure that our customers get the right answers. And being able to have that confidence leaving the field, to me, is kind of really everything of like where I see reality capture and field systems of, we try to strive to make the best of the best.
Yeah. Is there a bucket list item, maybe a famous like statue or something that you'd want to scan? Is there something on your list of like, oh, I'd love to scan that one day?
Ooh, I don't think so. I'm trying to think, because like, if there was something, I would want it to be something that I can go create a model of and then 3D print it. So like, I mean, the Eiffel Tower would be pretty fun to do, but I feel like everything that I've thought of has already been scanned, so it's like, it's not novel. So
yeah, there's already been someone that's tried it. Yeah, there is. If you ever make it to New York with your scanner, there's, they have the Big Bean in Chicago, which I'm sure has been scanned, but they made one in New York, and it's kind of squished between a building, and I think it would be fun to scan that one day. So if you're out there, let's scan that. Is there, conversely, something that you like absolutely hate to scan? Is there like a type of environment or something you're just like, oh, this is going to be a pain, like you just dislike?
Yeah, I mean, in general, it's feature deserts, so large open areas that have very little vertical structure. Those are the worst to scan, because it's very, like, there's nothing to really attach onto, so your cloud-to-cloud registration's not going to work.
Okay.
I mean, you can get creative. It's the same thing kind of goes in like a featureless tunnel, where, like, obviously, like a tunnel that's commercially being used and stuff, they're probably going to like maybe have prisms or something up, and kind of they'll be able to place permanent things. But for like feature deserts of like very open land, where like, I mean, I've scanned some things that I'd consider feature deserts where like I'm just parking my car, kind of using that as something to latch scans onto, and then throwing anything I have in my car, or like the yellow case these things will come with, but like just finding random objects to actually be able to give it some features so that you can actually do it. I mean, yeah, I think that's probably one of the biggest limitations of scanners is open fields are just not fun to scan, and there's a lot better tools for that job.
This is a new term for me, feature desert, but it makes sense. And I almost think that maybe that will be in the best practices of like, if you're in a feature desert, add your own features to help, which is maybe where targets come in as well, like just to give it something to grab onto. So cool. Well, thank you for joining our podcast. It was good to to sit down and chat with you on reality capture. Anything else you wanted to leave the audience with or say?
No, I don't think so. Thanks, Michael, for having me.
Yeah, thanks for your time, Alex.